The basic algorithm of intelligence, and this applies to animals, to people, and to AI, is that a system learns a model of the environment by interacting with the environment. In other words, you have an agent, which is a me or a computer or a dog or something. The agent interacts with the environment and therefore learns a model of the environment. And in some cases, that model might be predefined. So for instance, in my program for playing Othello, it pretty much had a predefined model of the world, and the world was just the Othello board. But in human, we deal with all kinds of environments. So we learn that environment by interacting with it. And then we use our model of the environment to predict the outcomes from possible actions, things we may do. And then we choose the action that produces the desired outcome. So that's pretty much, what intelligence is.
So, these things, desired outcomes, are, I guess, all sociology. We look at an environment, we learn from the environment, or at least this other entity does, and chooses things based on the desired outcome. The key is the desired outcome, right?
Yes.
In terms...
any intelligent system is going to have preferred outcomes, and that's its motive, that's its motivation. And so the motivation is really the key to the safety. And, that's the real issue with artificial intelligence is what are its motives? And that's a very mathematical thing. And I was fortunate to still have enough mathematical ability left in 2012 when I was 64 years old to write a couple of useful papers on the subject of AI motivation from a mathematical point of view. And so there's a whole lot of people out there. There's a whole community of people doing that kind of work now. It goes on. It's really deep and difficult work.
There's a school of thought, I guess, that says, listen, we want to obviously learn as much about our brain and about the processes that take place in order for us to either mimic or better the process in an artificial way. Is that what you subscribe to? Or, well, tell me about that, this sort of understanding the brain and consciousness,
Sure.
etc.
Yeah, that's very important. So if you think about it, deep learning, which has revolutionized AI in the last 10 or 20 years, is really inspired by our understanding of how the brain works. So deep learning creates these artificial networks of neurons and uses a sort of back propagation algorithm that's somewhat inspired by how brains work. And there's three things that really go into the development of artificial intelligence. And one of them is being inspired by how human brains work. Neuroscience understanding tells us how it works. Another component that goes into it is mathematics. So once we see how the brain works, then we need to get a mathematical handle on it. That's the way all science goes. Mathematics is sort of the language for precisely understanding nature, including our own brains. And so there's whole mathematical theories of intelligence and how AI should work and all that stuff. And then the third component is experimentation. So people build these deep neural networks, they try to understand them mathematically, and then they turn them on and see if they work. Can we beat the world's best Go player or something like that, And so those three components, and understanding the human brain is a very important part. It's one of three very important parts of the pursuit of AI.
So is this sort of work, as they're creating these neural networks, is this done in conjunction with neuroscientists, or is...
Yeah, for instance, I was for a number of years was going to the artificial general intelligence meetings, and they were always invited neuroscientists. There was always sessions for the neuroscientists to come and speak. There was always a keynote speaker who was a neuroscientist who was telling us things about, I think Stephen Grossman was a speaker in New York City. That was very interesting. But there's been a lot of different neuroscientists come and speak to that. And it's an important part. There's some interesting research. I can't remember the details because it's been a while since I've seen it, where people look at artificial intelligence algorithms. Specifically, I think they're reinforcement learning algorithms, temporal difference algorithm. And then they look at in the brain and they can see signals in the brain that are fairly clearly part of the brain's own implementation of that well-known AI algorithm. So here's an artificial algorithm, and then they look in the brain and they can say, yes, the brain is doing that.
How do you actually visualize that?
They're seeing neurons firing. So neurons fire, you know, they sort of go bang. And they're watching the firing of neurons relative to other neurons and relative to the external stimuli coming into the brain. And they're saying, yeah, if it's doing this algorithm, these things should be firing in this way, you know, and they.
Oh, so it's replicating this algorithm that did it by itself. Is that?
Yeah. So there's an algorithm that somebody wrote for a computer, and then they can see from the way the neurons are firing, they can say, oh yeah, the neurons must be doing that.
So is the implication, and again, I know this isn't necessarily your field, but I imagine as a curious person, you've thought about it. Yeah. I mean, are you of the mind, forgive or don't forgive the pun, that we are, I mean, that this is a series, that who and what we are, our consciousness is a series of basically mathematical processes, not dissimilar from those of a machine?
Absolutely. Absolutely. There are so many correlations between what's happening in our physical brains and what we observe in our behavior, that it's really clear, it's really obvious that our brains, our physical brains, are creating our behavior. And you know, we don't understand all the details of that. We're far from understanding all the details from that, but there's so many correlations. It would be a ridiculous coincidence if the physical brain didn't explain our minds.